Hey devs, welcome back. So, I finally completed this card game. It is now fully playable, and I can play it with 3 other players, which is controlled by a simple AI. So the game is called Big 2, and it starts off with the player who has the lowest card, which is the 3 of clubs, and he can play it with any hand. Then the game switches control to the next player, and the next player will try to beat the previous hand. If that next player happens to be me, then I have to play it myself. If the player doesn't have the cards to beat the previous hand, he can pass. The player who disposes all of his card wins the game. It's a simple app, really. It's easy to make, and this video will walk you through all of it. So let's begin. Let's recap what we have built so far. I created a new project and named it Big 2. I have a previous video on how to get started with Xcode, and I will leave a link above or on the description below. I then dragged all the 52 card images into the assets catalog. I have 2 versions of each card, 1x and 2x, 2x being the higher resolution. The next thing I did was to show a card in the view. I renamed the default content view to main view. This renamed everywhere the content view is used, even the file name. Then I dragged one of the cards into the main view. This created an image, which is another type of view, using the name of the card from the assets catalog. If I want to resize the card to occupy as much space, I can put the scale to fit modifier, but don't forget the resizable modifier as well, or else it won't work. I can also use the aspect ratio modifier using content fit if I want to maintain the aspect ratio of the card. Next, I tried to display multiple cards. I put these cards into a container view. An example of this container is a horizontal stack, or H stack. I created an array of names of cards. Then with for each loop, I iterate through the array and displayed each card by its name. For each requires a unique ID for the elements, and I just created one on the fly. Now, if I want to display more cards, I can just add the asset's name in the array. I then extracted this image view as a subview. In SwiftUI, it is encouraged to create small subviews as the view gets bigger. Then just pass the name of the card into this new card view, and it just worked as before. But the cards cannot be just strings. What we have are an array of names of cards. I needed a model to represent a playing card, a card struct that will have the properties rank and suit. For rank, I can have it as an integer, but now I will have a problem with Jack, Queen, and King. It can be 11, 12, and 13, but then I will need to have to do some conversion later on. What about Ace? In Big 2 game, it is one of the highest card, higher than the King. I can represent it as 1 or 14 because Ace can be part of a straight hand with Ace, 2, 3, 4, 5, or 10, Jack, Queen, King, Ace. And what about 2? It is the strongest card in Big 2, stronger than the Ace. And similarly with suit, I can have it as string, but then there is a problem of misspelling later on. So a rank cannot be an int, and a suit cannot be a string. So the best way to implement a card model is to have the rank with type rank and suit with type suit. I created an enum type for the rank and suit that contains its valid values, like aces, jack, queen, and club, hearts, diamond, and so on. The enum creates for us a powerful type. The order of the elements in an enum represents its value. So now with Big 2 game, I can just easily move ace above the king and move 2 as the highest rank. Same with suit. With my version of Big 2 game, club is the lowest suit, but there are some version of the game where spade is the lowest. Then it depends on which version you play, and I don't have to change any of the game logic to achieve that. I just move the order of the enum elements. Each of the card is associated to an image, and we are clever to name our card image as the concatenation of the rank and suit. I can easily create a string out of these types on the fly and use this name to display the card. But even better, I can put this card name in the card struct by creating a computed property card name. Now, each time I create a new card, the name of the card image is auto-generated in this card name, and I can use it to display the image from the asset catalog. To test this, I created an array of 5 cards and replaced the for each with this array of cards. It is no longer an array of strings, and I passed the file name as the card name. I also replaced the ID we created on the fly with the identifiable protocol. I changed the card view to accept a card type instead of a string, and the card view can now display the image by accessing the file name property of card. Another important model in our game is the player model. In this model is a property that will hold the player's cards, and another property to identify that this is my player. This will be a bool, and its initial value is false. I also assigned a name to the type array of cards by using type alias and named it stack. And we will now refer to an array of cards as stack. I created another test data for players. In Big 2 game, there are 4 players, and 3 of them are the opponents, and 1 of them is my player. So the my player will be true. The test cards were also increased to 13 cards. As in the Big 2 game, each player starts with 13 cards. Going back to the main view, I set up the playing area. The cards appear to be very small, as SwiftUI is trying to fit all 13 cards horizontally in the H stack while maintaining the aspect ratio. I used a lazy V-grid to display the 13 cards nicely. I already know what grid item spacing to use, so I will just plug them in. Now, I created 4 of these lazy V-grid, 1 for each player. For each can do this by iterating through the players in the array, and again, for each requires the elements in the array to be identifiable. Similar to how I did in cards, I will do the same in players. I then place this player's view in a VStack. The layout plan for this game is the upper half will display the opponent's cards, and the lower half will be the playing area and my player's cards. The geometry reader will give me the height and the width of the space allocated, and I use this to calculate the frame height of the opponent's view. I then just show the cards of the players who is not me, which are basically my opponents. In the lower half, I added a rectangle. This will be the playing area, and at the bottom, I added the cards of my player. And I know that this is always the 4th player in the array, and the cards will appear bigger than that of the opponents, as I will be interacting with it. I am now creating the game model struct, and the name of this struct is Big2. This model contains the main logic of the game. I first created the players similar to the test player array. I made it private, so it is only to be updated by this model. The game will start off by setting up the players. Again, I have the 3 opponents and then my player. Then I will deal the 52 cards to all the players. In the game, there will be a deck of cards. I created the struct for the deck. There is a function here that will create the array of 52 cards. I simply iterate in all the valid ranks and suits and create cards out of it. There is a protocol case iteratable that when applied to the enum gives us this special var all cases. I can also create a shuffle function, and this is easy as the array already has a built-in function called shuffle. These functions has to be marked as mutating because structs by default are immutable. If there are functions that modify the struct, it has to be marked as mutating. Now going back to the Big 2 struct, I now created the full deck and shuffled it. Starting off with a random player, I get 1 card from the deck while there are cards remaining in the deck, and then I added that to the randomly selected starting player. This draw card function uses the array function remove last that returns the last element in the array and at the same time removes that element from the array. Then I get another card then add it to the next player, and so on until there are no more cards in the deck. I no longer need these test cards as the player cards are now coming from the deck. Going back again to the main view, I created the model and initialized it, and then I replaced the test players as I am now using the players from the model. I will talk about Mvvm for a moment. Right now, I only have the model, which has our players, cards, and the main game logic that deals the 52 cards to all players. And they are all structs. And when structs are passed around, it creates a copy. It doesn't live in an area in memory like a class, where we get a pointer. And that is a problem, because I don't want to have copies of the model. I only want it to be in one place, and it will be the single source of truth. In order to make this work, I need one more component to complete the Mvvm programming paradigm of SwiftUI development. This is the view model. This will be a class, and it is named Big2Game. I put the model in here and made it private. The view cannot have direct access to the model. It can only do that through the view model. I initialized the view model once in the main view. Since the model is private, I need to provide like a window to access it. I created a var for players, which actually just returns the players from the model. Next, I wanted to be able to select cards in my players stack by tapping them. I have an on-tap gesture. For now, I just wrote the card that was tapped. But I created another mutating function that will find a particular card from the player's stack and mark it as selected. So in the card struct, I created a property selected, which is a bool, and I initialized it to false or not selected. Now when the card is tapped, the gesture will trigger and the function is called. As the model is again private, I created that function in the view model that calls the function in the model. This will look for the card and turn the property selected to true. In order to know that this is truly working, I raise the Y position of the card when it is selected. Now it is not working because the view model is not yet set to be observed for changes. The view model must publish the changes that happens to the model, and the view can subscribe for these changes. Now it is working. The view is always observing the changes in the model. It knows whether the property selected of the card has changed and will change the Y offset position accordingly. The next function I created was to look at the selected cards and tell its type. I created another enum for the different types of card hands, and I will name this enum hand type. I started with invalid, then the valid types. That would be the single, pair, three of a kind, straight, flush, full house, and so on. This function will take the stack of the player, then identify its type. I display the result in the playing area by writing the enum type of the cards. Then I created the rules. If there is only one card, then it is a single. If there are two cards and the ranks are the same, then it's a pair. I tested these two rules first, so I only passed the selected cards to the function. Okay, one card is a single, two cards of the same rank a pair. If they're different, then it's invalid. Let's continue with the remaining rules. If there are three cards and all the ranks are the same, then it's three of a kind. Now, for the 5 cards, the cards will be sorted by rank first. I put the function as an extension to the type stack, where element is a card type. Therefore, this function will not be available to just any array, but only if the element is a card. So the sort iterates to all the cards in the remaining cards array and compares the cards and gets the highest among them. In order to compare ranks and suits, there is a protocol called comparable. Then I provided a raw value into the elements with an int. Now I can compare the raw values using the greater than or less than signs and determine which element is higher or lower. The highest among the remaining cards will be moved into the new sorted array and repeats this process all over again until there are no more remaining cards. Now that the cards are sorted by rank, I can determine 4 of a kind by comparing the first 4 or the last 4 cards if their ranks are the same, as there are only 5 cards. To determine a straight is to go through all 5 cards, and if the difference between two adjacent card value is 1, then that would be a straight. For flush is easy. Just compare all suit, and if it is the same among all 5 cards, then it's a flush. Let's test these rules again. The game starts with the player who has the lowest card. The lowest card in this game is the 3 of clubs. This function will return the player who has that card. The array has a function contains where that will find if the array has the element card that is a 3 of clubs. The next function I created is called activate player. This will tell the player that it is his turn to move. I created an active player property in the player struct, and this will be turned to true whenever it is that player's turn. I tested to see if it can determine which player has the lowest card, then activate that player. I also created a player name property so I can prove that I am activating the correct player by writing its name. I named the players player 1, player 2, and player 3, and then me. I will use the onAppear view function to trigger the function. The onAppear is called when the view appears on the screen. Now I call the function findStartingPlayer and write the player's name. When the player is activated and it is not my player, the AI will generate the cards to play. I easily created a computed property that will always return the active player, and I don't need a function for that. This computed property can search for the player where the active player property is set to true. Then I can just refer to this computed property whenever I need the active player. The next important function is the brain of the AI. I called it getCPUHand, and this will return the cards that the opponents are going to play. The first step is to count all the ranks and suits of the player's stack. I sort them by rank and did a for loop and count every occurrences of the ranks. I displayed the results in the debug window. I called the activate player for the player with the lowest card, and this called the getCPUHand. Player 1 has the lowest card, 3 of clubs, and there are 2 jacks, 1 queen, 2 tens, and 2 threes in the player's stack. So this looked good. Then I created 2 var counts. If there are 2 or more occurrences of a rank, a pair for example, I put them first in count 1. Now if there are more than 2 occurrences, like a 3 or 4 of a kind, then I put them in count 1. But then if count 1 already has a value, that value is copied to count 2 first. Now at this point I'm just trying to detect which hand type is possible in the player's stack. I am not yet generating the actual hand. I created bool variables. A pair exists if the count 1 is greater than 1, and 3 of a kind if greater than 2, and 4 of a kind if greater than 3. Now, full house exists if count 1 is greater than 2 or has a 3 of a kind at least, and count 2 has a pair at least. To detect a straight, I checked if the current rank is greater than 0 and the next 4 consecutive rank from the current is also greater than 0. Then there is a straight. I just need some special treatment to ace and 2. Flush is the easiest. I just need to check if any of the suit occurred 5 times. Then there is a flush. Now that I know what are the valid hands that exist on the player's stack, I can now create an array of valid hands. I have this function called combinations, which will return a combination of cards based on the value of k. For example, if k is 1, then combinations will return from a given stack combinations of single cards. If k is 2, then the function will return possible combinations of 2 cards from a given stack. Now I will not ask for 2 card combinations for all of the cards. There's no point of doing that. I will only ask for combinations where I have 2 occurrences of the rank and pass that to the function. Once I get the combinations of 2 cards, I can check if the type is a pair. Then I will add it as a valid hand. Now I did this again for 3 of a kind. This time I will ask combinations of 3 cards. By passing to the function only cards where the rank occurred 3 times. Then combination function will return 3 card combinations. And I can check if the combinations are of 3 of a kind, and I will add that as a valid hand. It is again the same thing for 5 cards. I will ask for 5 card combinations, and I will pass the cards if there was a full house, those whose rank occurred 2 times or more, or if there was a flush. Then I will pass the card if the suit occurred 5 or more, or if there was a straight. Now this is just a lazy implementation. Why not just pass all of the 5 cards? Then I will look at all the possible 5 card combinations and check that they are a valid hand type. Then I will add it as a valid hand. Now that I have a list of all valid hands, I have to choose one for the player. I have to play a hand that is higher than the last hand that was discarded. So I created an array of discarded hands. If the discarded hands array is empty, it means this is the first play. So the hand of the active player must include the lowest card, the 3 of clubs. But if it is not the first play, then I have to look at the last discarded hand and must beat it. So for that, the hand must have some kind of a scoring system. I formulated a scoring system where the suit score is just a raw value. Then for the ace, I just added like a high number, like 1000. Then for 2, another high number higher than the ace, like a 5000. Else, every other rank, I just multiplied it by 100. And for the hand type, I multiplied it by 1000. You can create your own scoring system. The player can discard a hand if the score of the hand is greater than the score of the last discarded hand, and if they have the same count. Or if the player who discarded the last card was also the same player, meaning no one was able to beat the last hand that the player discarded, then he can throw any hand type. I also sorted the valid hands by its score, by descending value. And by doing this, the player will always throw a hand that has the highest score. Now that I have decided which hand to play, I now created a function to play and discard the hand. First, I marked the cards as selected. Then the function filtered all the cards that are selected and removed them from the player's stack, then puts it in the discarded hands array. In the playing area, I need to show all the discarded hands. As discarded hands is an array, I did a for each, then created a lazy vgrid to display the hands. I needed to fix the layout of the cards first. For that, I created again test data of 5 cards. I played with the spacing and scale effect to make it look nice. After the first player played a hand with the lowest card, I moved the turn to the next player. I created another function to get the next player from the current. Just add 1 to the current player index. And I added this %players count so that the index is just within the range of 0 to 3. Then I deactivated the current player and activate the next player. I triggered the next player manually for now by calling it in the next button. Aside from showing the discarded hand in the playing area, I also showed what type of hand it is and which player played that hand. I put the text in a VStack so it appears just below the discarded hand. I also wanted to make this playing area better by displaying the last 2 discarded hands. The previous discarded hand will show at the back of the current discarded hand with an opacity and smaller than the current. This is easily done as this is a Z-stack. I can just do this by placing the view behind it. I can still use the same lazy vgrid, but I put some conditions on the scale, opacity, and offset on how it will display if it is a previous discarded hand or the last discarded hand. The other hands will no longer show, only the last 2 discarded hands. Now that I know that the AI for the opponent is somewhat working, I can now turn back the opponent's stack so that I cannot see them and I cannot cheat on the game. I added another property in the card struct called back. And if this is true, it will display the back of the card. I have a card called back in the assets catalog. At the moment, the game starts during the onAppear function, where it triggers the first player when the main view appears on the screen. Then manually, I clicked on Next in order to trigger the next player. Now I created a timer to do all of that, so it will be automatic. I receive a timer trigger every second, and when I do, I updated some counters so that when it reaches 5, basically every 5 seconds, it will activate a player. I created this active player var in the model. I guess I have to put this in the view model as I will need some detection over at the view as to which player is going to make a move. And I don't want the AI to be called straight away when a player gets activated. I have all these functions in the view model so that I can call them in the view when it's appropriate. When I activate the next player, whether it's the first player or a subsequent player, this is when I populated this active player var. What I am doing now is just moving functions around, trying to see where it is best to call them. There is another function in view called onChange. Here I can detect if active player has changed. Now that I've moved the active player into the view model, the view can observe for any changes and can do something when that happens. This function activate next player currently gets the next player and activates it. Now I broke this down as I want more control of the functions being called. I will just make this get next player and will call the activate player separately to activate it. Now I can see that every 5 seconds the active player is changing. So now I can call the AI in here. I made the AI available in the view model and called it when the active player changes, and it is the opponent player. Then for every card in the hand, I called the select function, then played the selected cards to move them to the discarded array. It's not really clear which player is having a turn, so I will make a function to make the player's view appear faded in the background while the active player is the only one showing clearly. And I will do this by adjusting the opacity of the player's view. Just a few more improvements here on the select function. Instead of doing the for loop out here, I let the function itself do the for loop, so the code is a lot cleaner. I wanted to make the time for my player to be longer. 5 seconds is not enough to make a move, so I will assign a temporary value for now, minus 100 for example. So this gives me like 100 seconds to make a move. Of course, I will adjust this later. Then I change the button and call it play. And just by assigning the counter back to 0, it will move on to the next player after 5 seconds. Now the play button will be disabled or enabled depending on the play at hand. For example, if I am not the active player, then it will be disabled. But if it is my turn, then it is enabled. However, the text is changing as well. If I have not selected any card, possibly I wanted to skip my turn and pass. However, if I selected some cards to play, then the text will show play. Making this play button even better, it will only be enabled when it's my turn, and the hand that I selected is playable. Playable in the sense that it is a valid hand to beat the previous hand that was discarded. Or if it is me who is making the first move, that it must include the lowest card, which is the 3 of club. Otherwise, it is not playable and the button will be disabled. The other time it will be enabled is if there are no cards selected, for which maybe I will skip my turn and pass. I created the function that will play my selected card. It will remove it from my stack and put it in the discarded hands. I don't need to check whether it's a valid hand, as that is already done when it enabled the play button. I know it will always be a valid hand to play. Just a few more tweaks to start with the button as pass when it's my turn, as there are no cards selected. I am now going to do some animation. The first thing I want to do is to raise the card when I select or unselect. I'm going to make this appear to be sliding up and down. Next, I want to see the cards being dealt also animated, like it is coming from one deck and distributed to all the players, not just appearing instantly. However, when I called the deal routine, the card is already dealt and there is nothing to animate. Animation only works when something is changing. So I created this array of dealt cards. The purpose of this is just for animation. As I've mentioned, the cards are already dealt at this point. I just want it to appear on screen animated. I created this deal animation, which is a kind of delay when the cards appear on screen. I created a deck of 52 cards and I will put it in the middle of the playing area. The animation of the cards will start from this deck. As the cards are removed from this deck, it will be added into the player's stack. There is another animation that I wanted to happen, and that is the card will fly from the deck in the middle through to the player's area. There is a magic modifier called Match Geometry. What it does is, I provided the card ID and the namespace. The namespace is the same between the source and the target view, and I provided the card ID. When the card with this ID travels from one source container view into the target container view with the same namespace, it will be animated. I did the same thing when the player discarded the cards into the playing area. I animated the cards coming from the player's stack into the playing area. Again, I created an array of discarded cards for animation purposes only. The ID of the cards that are discarded into the playing area is added into this discard array of card IDs. And again, I match the source and destination namespace as well to get an animation moving from one container view to another with the Match Geometry modifier. I get all these warning messages. I found out that this is because the animation is confused as it is called in both container view, and maybe it isn't syncing properly. Maybe the card isn't removed yet from the source and I am trying to call it in the destination as well, or something like that. But to resolve this is to have the animation only on the destination, and the source will match it somehow. I noticed that the opponents are playing the lower cards first. I think it's due to this sorted by hand score. When I do a for loop, it gets the lowest card first. It is kind of boring as the game is mostly throwing singles. There are no pairs or 5 cards. But I can change the order of these hands to be high cards first. Or I can also do random. So I will add a property to the player, which is the playing style. And I created an enum of playing strategy. Random, low cards first, or high cards first. Then I will make the first player play random cards, and the second player play high cards first, and the third player will play low cards first. And one last thing, I needed to detect a game over scenario. The game over occurs when one of the players discarded all of his cards. So I created another published var called game over, where I will check the active player after discarding his cards to play. I will check if he has now no more cards left. If yes, then this will be true. And if it is true, I will change the text here to show game over, and then I will turn off the timer. That's it for this video. I know it is a very long video for you, but I hope you picked up something useful. I was away in a long time and thank you for sticking around. And if you like this, you would want to check out the first 2 parts of this series where I talk about the foundation in a more detailed way. Well, see you in the next one, and happy coding!